So sometimes we're going to want to represent, or we might be asked to represent quadratics as graphs. So quadratics are parabolas, and these have a very signature shape of being sort of a curve. So if it's in the form y equals ax squared plus bx plus c, then the parabola will be a positive parabola and it will look like this. If it's in the form y equals minus ax squared plus bx plus c, then it will be in a negative parabola and it will look like this. Just a note for this bit, and just for the whole topic of A level in general, your sketching doesn't need to be precise, but there are a few key features that they could ask you to label that I'll go through now. So as I said, there are three possible key features that they could ask you to label on a quadratic graph when you sketch it, and I'll go through them now. For this entire bit, we'll use y equals 2x squared minus 6x minus 8. So the first thing they could ask you to label are the roots. This is when y is equal to 0 and it crosses the x-axis. So there are three possibilities for how many roots there are. There can be two roots for a quadratic to have. So for example, if it's positive coefficient of x squared, then it will look like this, where there's a root there and a root there. And if it's a negative coefficient of x squared, then it will look like this, where there's a root there and a root there. There could be one roots, or this is quite commonly called equal roots. Then it will look like this, where it will touch the x-axis, but it won't cross it, it will just touch it, and there will be a root there. And for minus ax squared, it will look like this again, where there will be a root there. And it could have 0 roots, where it doesn't cross the x-axis at all. So for ax squared, this could look like this, and for minus ax squared, this could look like this, for example, where it doesn't touch the x-axis. So the way you find roots is just to make y equal to 0. And then when you do this, you just have a quadratic equation which you can just solve. So using a calculator earlier, I found that x here is equal to 4 and minus 1. So therefore, that we know that the roots exist when x is equal to 4 and when x is equal to minus 1. Now here there are two solutions for x. There can be one solution for x here, and that would be where there be one root, or there could be 0 solutions for x when it has the I on the calculator, and that's when it has 0 roots. So the second thing they could ask you to label is the y-intercept. This is when x is equal to 0 and it crosses the y-axis. Now, unlike roots, where it could vary, there will always be one y-intercept and only be 1. So it could either be positive, or it could be negative, like that. So the way you figure out y-intercepts is really easy. The y-intercept will just always be the number at the end of the quadratic. If you think about this enough, this is simply because x is equal to 0. So everything else will be times by 0. So the y-intercept will just be the number at the end. So here, the y-intercept is equal to minus 8 for our graph. Best way to remember this is in the just the quadratic form ax squared plus bx plus c. C is the y-intercept, the letter at the end. The third thing that they could ask you to label, they're less likely to ask for this, but they definitely could still ask it, is the turning point. Now, the turning point is exactly what it sounds like. The turning point is the point in which the quadratic turns. So when it's a positive coefficient of x squared, it's this minimum point here. And when it's a minus coefficient of x squared, it's this maximum point here. So there are three ways that you can find the turning point. The first one is, again, you can use your calculator. So if you put the equation into the calculator, as I explained in the factorization video, and you get the roots, and you press equals continuously, you get to something called the min of y equals ax squared plus bx plus c, and this will give you the minimum point because we have a positive coefficient of x squared. If it's a minus coefficient of x squared, it will say the max of y equals ax squared plus bx plus c instead, and it tells us that the x coefficient is the x value is 3 over 2 and the y value is minus 25 over 2. Now, obviously, this is the easiest method. The one thing I would say about this method is, unlike factorization and solving quadratic equations, etc., I would say that they are more likely to want working and a method, like giving marks for a method, than the other ways. The best way to assess this is if you do the question and you notice that it's for like a considerable amount of marks, I would, just to be safe, use one of the other two methods that I'm about to explain. But what's good about the calculator is you can check if you're right or not by plugging it into the calculator and seeing what the turning point is. The second method that you can do it, this is by far in my opinion the best of the two methods that I'm about to describe, is you can find the midpoint of the roots. If you think about it, the turning point, the x-coordinate of the turning point is going to be the midpoint of the two roots because the quadratic is symmetrical. So what you can do is you can find the midpoint of our two roots up here, which is 4 minus 1, and that is 3 over 2, and that's what the x-coordinate is equal to. I could do that in my head. The way that I do it is I minus a quantity from the top value and add the same quantity to the bottom value to get a new smaller range, and the midpoint of that range is the same as the original one. So for example, for the 4 minus 1, I minus 2 from 4 to get 2, and I add 2 to minus 1 to get 1, and the midpoint of 2 and 1 is the same as 4 minus 1, but obviously you've got much a smaller range, so it's a lot easier to work with. If you don't like doing that, or sometimes they could give you roots that have quite complicated fractions, or possibly they might even have surds, in which case there's another way you can do it, is you can just add the roots together and divide them by 2, and that will also give you the midpoint. But this gives you the x-coordinate, and the way you get the y-coordinate is just subbing it to the expression, the equation up here. So you would do that by saying y is equal to 2 3 over 2 squared minus 6 3 over 2 minus 8, which is equal, if you use your calculator, to minus 25 over 2. So therefore you can get the turning point as 3 over 2 minus 25 over 2. And you know that this is right because it's the same value up here that the calculator gave as the turning point too, because the turning point up here was also 3 over 2 minus 25 over 2. Obviously the downside with this method, the midpoint of roots, is that if you have 0 roots, you can't use it because obviously you can't find the midpoint of the roots because you don't have any.